Welcome to The Explainer. I am incredibly excited to be your guide today because honestly, we're looking at one of the most awe-inspiring achievements in all of human history. We are exploring the 35-year legacy of NASA's iconic Hubble Space Telescope. This isn't just a story about some satellite floating up there. It's the story of how a single, beautifully complex machine literally revolutionized our understanding of the cosmos. It's returned observations that have touched absolutely every single area of astronomy.
Okay, let's dive right into this with a perfect example of what Hubble does best. What we're looking at is the 30 Doradus Nebula. It's this incredibly fertile star-forming region located in a satellite galaxy just outside our own Milky Way. And the sheer scale and beauty here, it's almost hard to comprehend. We're seeing hot gas completely energized by a central star cluster. That's the aqua color you're noticing. Then there are the glowing edges of gas and dust clouds in pink, and those cooler surfaces in reddish-brown. It is a dynamic, violently active, yet just incredibly beautiful cosmic nursery, captured with breathtaking clarity.
Seeing something like that really forces us to ask a pretty big question. What does 35 years of peering into the absolute unknown actually look like? Well, the story of Hubble is essentially a hero's journey. It's the tale of a telescope launched to give us a totally unobstructed view of the universe, flying way up high above the distorting effects of Earth's atmosphere. And in doing so, it fundamentally shifted our place in the universe. It rewrote the textbooks and showed us things we quite literally could not have dreamed up.
This whole grand ambition was perfectly captured by astrophysicist John Buckhall. He noted that the most important discoveries will provide answers to questions that we do not yet know how to ask, and will concern objects we have not yet imagined. I just love that. Hubble wasn't built just to get a slightly clearer picture of the stars we already knew about. It was designed to pull back the curtain on the unimaginable. But, as with any great hero's journey, the path wasn't exactly a straight line to success.
Part 1. A grand ambition and its early hurdles. Let's get into it. So, Hubble's journey actually started off with a massive, near-catastrophic challenge. The telescope we all rely on today almost didn't make it past the starting line. On April 24, 1990, the Hubble Space Telescope was launched with immense fanfare by the Space Shuttle Discovery. But shortly after launch, complete disaster struck. Scientists realized there was a spherical aberration in the telescope's primary mirror. Basically, its vision was completely blurred. But here's where the absolute genius of Hubble's design shines. It was built to be serviced in orbit. So in December 1993, NASA executed the first of 5 incredibly high-stakes astronaut servicing missions to fix those optics.
And this perfectly captures what that human ingenuity looked like. We've got the solitary telescope floating out there in the vastness of space, but then we also have astronaut Jeffrey Hoffman during that critical first servicing mission. He's out there carefully removing the Wide Field and Planetary Camera 1. Now, just to put this into perspective, down here on Earth, that camera is about the size of a mini grand piano and weighs 610 pounds. Up in space, sure, it's weightless, but it still have the exact same mass and momentum. Just imagine trying to carefully maneuver a grand piano in zero gravity while locked inside a bulky spacesuit. It's wild, and that mission absolutely saved the entire project.
Because of that daring rescue and the 4 servicing missions that followed, Hubble was able to achieve something truly staggering. Over the course of its 35-year lifespan, this revitalized observatory has made more than 1.6 million observations. 1.6 million! And hey, that number is still going up. From small colliding asteroids to the most distant star-forming galaxies, Hubble's instruments have just been tirelessly gathering data across the ultraviolet, visible, and near-infrared spectrums.
But what do 1.6 million observations actually translate to for us? Well, they fuel the science that changes our world. Hubble's data has literally been the foundation for over 20,000 peer-reviewed scientific papers. And it doesn't stop there. Those papers have been cited over 1 million times by other researchers. The data even contributed directly to a Nobel Prize in physics. So it's definitely not an exaggeration to say that this single machine fundamentally rewrote our scientific textbooks.
Part 2. The Dark Ages. Looking back in time.
So, what exactly did all those thousands of papers discover? Well, I want you to imagine looking into the deepest, oldest, and darkest parts of space, trying to find the very first lights that ever turned on in the universe. What's really fascinating here is the sheer scale. We're talking about the Hubble Ultra Deep Field. This single visual is the result of a 1 million-second-long exposure, and the actual patch of sky it covers, it's equivalent to looking through the eye of a sewing needle held at arm's length. Seriously, a tiny little speck. Yet within that needle-sized patch of sky, Hubble captured over 10,000 individual galaxies.
By peering this deeply, Hubble is actually capturing light from some of the oldest galaxies ever seen. We're talking over 13 billion light-years away. These are the very first galaxies emerging from the Dark Ages, which was that era just before the first stars illuminated the cosmos. Hubble quite literally let us see the dawn of the universe.
Part 3. Our solar system, local mysteries. Now, Hubble's power isn't just restricted to the extreme edge of time. Let's bring our focus a little closer to home. Hubble has been absolutely instrumental in solving mysteries right here in our own cosmic backyard, helping us map and understand our solar system in unprecedented detail. Just think about these incredible local discoveries. It found the best evidence yet for an underground saltwater ocean on Jupiter's moon Ganymede, which is a massive deal for the search for life. It mapped huge objects like Ceres and Vesta out in the asteroid belt. When NASA was getting ready to send the New Horizons spacecraft to Pluto, Hubble actually stepped in and discovered 4 previously unknown moons orbiting the dwarf planet just to help plan the flyby. It even spotted Arrokoth, this ancient cosmic object deep in the Kuiper belt, serving as a critical target for New Horizons' continued journey.
Part 4. Alien Worlds, Searching for Exoplanets.
Speaking of the search for life, let's pivot to one of humanity's biggest, most enduring questions. Are there other Earths out there? Are we alone? Well, when it comes to the search for alien worlds, Hubble has been an absolute pioneer. Think about this. When Hubble launched in 1990, humanity had 0 confirmed planets outside of our solar system. 0. Today, we know of over 5,000. But Hubble didn't just help find them. It actually took the very first measurements of exoplanet atmospheres. It has detected the crucial atmospheric building blocks for life on these alien worlds. We're talking about sodium, oxygen, carbon, hydrogen, carbon dioxide, methane, and water vapor. We can literally detect the basic organic components for life light years away from Earth.
And in one of its most astonishing discoveries, Hubble observed the first known system of 7 Earth-sized planets orbiting a single ultra-cool dwarf star. The conditions there could potentially allow liquid water to survive. Hubble's observations revealed that at least 3 of these exoplanets have compact atmospheres similar to Earth and Venus, rather than the puffy, unlivable atmospheres of gas giants. It's incredible discoveries exactly like this that paved the way for all of our future planetary exploration.
Part 5. The Unseen Universe. What awaits? As we look toward the future, I want to bring us back to where we started, the sheer awe-inspiring visual majesty of Hubble's legacy. Because beyond all the hard data and the chemical readouts, Hubble has given us this incredible gallery of cosmic art that fundamentally connects us to the universe. Take this mind-blowing star, V838 Monocerotis. It's located 20,000 light-years away on the edge of our galaxy. What you're seeing is the dust surrounding a variable star producing a breathtaking light echo. Basically, the light from the star's outburst is illuminating the surrounding dust clouds as it travels outward. It creates this mesmerizing, swirling visual that looks almost like a painting hanging in the dark.
And this brilliantly illustrates the sheer dynamic power of space. Here we have 2 spiral galaxies, NGC 2207 and IC 2163, and they are passing right by each other. The violent, immense tidal forces from the larger galaxy are actively distorting the smaller one, flinging out stars and gas into these massive streamers that stretch out 100,000 light-years into the void. It's a cosmic dance on a scale that is almost impossible to wrap our heads around.
So, the crucial point is this. We've talked about the incredible launch, the daring rescue, the 1.6 million observations, the deepest fields of time, and the atmospheres of alien worlds, but here is the most humbling, surprising fact of all. Despite 35 years of tireless work staring out into the dark, Hubble has only looked at 1/10 of 1% of the universe. Which leaves us with this final, incredibly provocative thought. If 35 years of sheer dedication, brilliant human engineering, and over 1 million observations have only revealed 0.1% of the cosmos, what in the world is waiting for us in the remaining 99.9%? The unseen universe awaits. And honestly, thanks to Hubble, we've never been more prepared or more excited to explore it. Thank you so much for joining me in this explainer, and as always, keep your eyes on the stars.